This video will teach you how to solve rational equations. You've solved rational equations before by solving proportions, which is where we're going to start with this here. Solving proportions is done by using cross multiplication, which you take the diagonals of two fractions equal to each other, multiply them together, and then eventually solve for x. So we're going to use that strategy to kind of get started here with how to solve these. But what we're going to also take a look at is if you have more than two fractions in an equation, how do we solve and get x? The other thing we're going to see with this is the possibility of what we call extraneous solutions. You've dealt with this a little bit in Algebra 1 with some word problems, maybe with factoring, but not a ton. Extraneous solutions basically occur when you solve a problem, you get a couple answers for x. Mathematically, they somehow worked when you solved them, but then you plug them back in and they don't work. That's what an extraneous solution is. So we're going to see a little bit of that here as we go through these problems in this video. So let's start with a couple basic ones. In these first couple of examples, if I have one fraction equal to another, I don't have to do anything fancy. I just have to cross multiply. So number one, I'm going to put these two diagonals together. Make sure when you are multiplying anything with an expression, put parentheses around it so we make sure everything is distributed correctly. So this setup should look oddly familiar. You've cross-multiplied in many other math classes. All we have to do now is work on getting x by itself. So you can see the work here that I'm showing out for that. We distribute the 3 on the left. We'll distribute the 9 on the right. And then it's just a matter of let's go ahead and get x by itself. X is going to be -2 when you solve this. Now, to check it to see if a solution is what we call extraneous, basically what will happen sometimes is you might get an answer for x where if you plug it back in, like I said, it doesn't work. But where you really need to focus on it not working is in the denominator. So if I were to plug the -2 into our denominators, -2 plus 1 is -1. And the other one, -2 times 4 is -8 plus 5, which is -3. As long as when you plug that in, the denominator does not come out to 0, you're in good shape. Okay, because keep in mind, if you have a denominator of 0, you're not allowed to divide by that. So really, when it comes to finding if a solution is extraneous, that's what you need to be on the lookout for. If I plug in that number, does it give me a denominator of 0? So that's about the only new thing we're going to look for when we do cross multiplying in this case. So same thing here for number 2. We're going to cross multiply. 3 times x minus 7 equals 5x times 2. So we'll get 3x minus 21 on the left, 10x on the right. Subtract the 3x, we'll get -21 equals 7x. Divide by 7, -3 equals x. Same deal, we plug it quickly into the denominator. 5 times -3 is -15. -3 minus 7 is -10. Again, since these are proportional here, your denominators aren't going to match. As long as they're not 0, you're probably in good shape. So those two answers are great. All is well with that. Now, where it gets a little bit trickier is when we have more fractions. Okay, if it's one fraction equal another, we cross multiply. When you've got addition or subtraction being thrown in with your fractions, that's when we have to really pay attention here. So again, we're going to use all those skills that you've learned in this chapter about how to add, subtract, multiply, divide, how to do all that stuff and apply it to equations. There are two ways that you can solve these, and it's really dependent on how the fractions are set up. So you can see both methods up top, and I'm going to use both in this particular video here because you'll see with some of these, it's going to make sense to use one method over the other. So if you have a problem, so the first method that says here, if you have multiple fractions that have a common denominator, combine those like you would using solving a regular equation. So you'll see some of these problems have multiple fractions where the denominator is the same. Maybe not all of them, but most of them. Combine them like you would with regular equation math. What will happen is more than likely, it'll turn into an easy cross multiplication problem and you can solve. The other method is if none of your denominators are the same, we need to go get common denominators. And we're going to go ahead and figure out our solutions, finding an LCD, and then setting all the fractions equal to each other and then just kind of going from there. So there's two different ways we're going to solve it here, and we'll talk through each of those throughout the many examples that are in this video. So let's look at number 3. I have 5 over x plus 7 over 4 equals -9 over x. I have two fractions out of 3 that have a common denominator of x. So I'm going to go ahead and use that first method where I'm going to get the fractions with the same denominator. I'm going to get them combined. So using basic equation math, if I have a positive 5 over x, I'm going to throw it over to the other side and combine it with the negative 9 over x on the other side. Because again, they have the same denominator, so that makes it easy to combine. That leaves me with 7 over 4 equals negative 14 over x. That makes it much easier to solve because now this just turns into a cross multiplication problem. So I can just go ahead and do what I did in the first two examples. 7 times x equals negative 14 times 4. So I would get 7x equals negative 56. Divide by 7, x equals negative 8. Again, I'm going to check to see if that solution is extraneous. What makes this easy is, again, the denominator is just x. I got negative 8. It's not 0, so we're in good shape. Now, the fourth problem here, I look at this, I don't see a common denominator anyway. I have just straight up 1. I have a denominator of x minus 5. I have a denominator of x. In this type of problem, what I'm going to actually find is go find the least common denominator. So what I'm going to do for this is, again, let's look at our denominators that we have. Nothing is factorable, so I kind of just have to take everything at face value. I need an x, and I need an x minus 5. Keep in mind, for my big 1 that I have, my denominator of that would just be a 1. Including 1 as part of my LCD is kind of irrelevant because we know multiplying by 1 doesn't do us any good. So, we're going to make sure every one of these fractions has a denominator of x times x minus 5. So, my first fraction is 1 over 1 times x minus 5 over x times x minus 5. Minus 8 over x minus 5. It's missing that x, so we're going to make sure it gets multiplied by x over x. Equals 3 over x times x minus 5 over x minus 5. So, here's what will end up happening here. I'll end up reducing this, again, combining some things a little bit here. I'll have x times x minus 5 over x times x minus 5. Minus 8x over x times x minus 5. Equals 3x minus 15 over x times x minus 5. And I guess that means also I can go ahead in the first one, I kind of jumped the gun with that. Let's go ahead and actually multiply that together like we do all the other numerators. We'd have x squared minus 5x. Now, here's a fun little math trick. When I combine these together, the nice thing about this, so I can go ahead and look at this problem and say, they all have the same denominator, okay? So I can combine what's on the left here. I'll have x squared minus 5x minus 8x over x times x minus 5 equals 3x minus 15 over x times x minus 5. Here's a fun little trick. When all the fractions have the same denominator, because of the way that you'd have to, again, cross multiply, you're going to get a lot of things that will cancel out anyway. The denominators are no longer relevant. I can just take the numerators and set them equal to each other. So I can go ahead and say, hey, look what I got here. X squared. I'm going to combine that and make negative 13x. And set it equal to the other numerator. Because of the fact that if I cross multiplied, I'd have the x times x minus 5s on opposite sides. They'd cancel anyway, so there's no point in keeping them. Let's just get rid of them. So, keep in mind, I have to solve this equation still. So what I'm going to do is I'm going to subtract the 3x, subtract the 15 to each side. Excuse me, I'm going to add 15 to each side. Make sure your signs are right. So I'd have x squared minus 16x plus 15 equals 0. It's a trinomial. We're going to factor it. So what multiplies to 15 adds to negative 16. X minus 15, x minus 1. My two solutions, I get 15 and 1. If I plug both those numbers in for x, 15 checks out and so will 1. It won't break my denominators and make 0 out of anything. So I'm done. That's my answer. Okay, so the problems that have no common denominators, they're going to take the longest because you need to get a least common denominator. So again, you can see that process through there. So it's using a lot of what we talked about in the last couple of videos here with how to add and subtract and all those things. A lot of LCD work. But again, you're going to use that pretty heavily when you have when all of your fractions have nothing in common denominator wise. You're going to see that again here in the fifth example, where if I take a look at my denominators, I see an x minus 3, an x squared minus 9, and an x plus 3. x squared minus 9 is the same as x minus 3, x plus 3. So what we'll have to do with this here is I see x plus 3s and x minus 3s scattered about here. My LCD is going to be x minus 3, x plus 3. So what I'm going to do here, and I'm actually going to erase some of this off the screen so I have some room to write this out, is I'm going to go ahead and make sure everything gets affected properly. So 3 over x minus 3, we're going to multiply that by x plus 3, equals 4x squared over x minus 3, x plus 3. Since it already has both pieces, I don't need to add it. I don't need to multiply it by anything. Minus 2x over x plus 3. That needs an x minus 3. So I'm going to go ahead and simplify this. So on the left side, I'd have 3x plus 9 over x minus 3, x plus 3 equals 4x squared over x minus 3, x plus 3. Minus, that ends up being 2x squared minus 6x over x minus 3, x plus 3. Now, all of them have the same denominator, so once we get to that point, since it's in the equation, I can just basically make them go away. So that'll leave me with 3x plus 9 equals 4x squared minus 2x squared plus 6x. Keep in mind I'm applying that minus sign to both of those terms. And now we're just going to simplify everything. So I'm going to move... Well, we'll do this in a couple ways here. So I'm going to go ahead and combine my like terms on the right side. So I'll have 2x squared plus 6x. Move away the 3x and the 9. So I'll have 0 equals 2x squared plus 3x minus 9. Now we need to factor that. So this is where our diamond's going to come into play. So we need to figure out what adds to 3, multiplies to 8 times c, which is negative 18. So it would be 6, negative 3. So I can rewrite this as 2x squared plus 6x minus 3x minus 9. Group it. So I would get, let's see here, we take out a 2x, be left with x plus 3. Take out a negative 3, be left with x plus 3. So my factors would be 2x minus 3 and x plus 3. We set them each equal to 0. You'd get an answer of 3 halves and negative 3. Now, this is a case where one of these is going to be considered extraneous. 3 halves I can plug into any of those denominators and we're not going to have an issue. It's going to spit out a number that is not 0. But if I plug in negative 3, it's going to be a problem in the denominator of the 4x squared and the 2x fractions. Because if I plug in negative 3 for x in both of those problems, it's going to give me a denominator of 0. That's a problem, and that doesn't work. So negative 3 is considered to be extraneous. My only true answer for that is 3 halves. So let's take a look here again. We're going to see more of the same thing. Again, 4 and 5 are definitely the longer ways to do it, but it's the most effective way to do it. Again, you will see some problems like number 3 where you can get a couple of common denominators and be able to do some cross multiplying. You're going to see that here in example number, looks like number 7 here. We'll get to that here in a second. So let's look at 6. Same idea. We've got ourselves three terms here, all with different denominators, so we need an LCD. We see a denominator of 2, 1, and x. LCD is going to be 2x. So I can take the first fraction, multiply it by x over x, take the second fraction, multiply by 2 over 2, and take the third fraction, multiply by 2x over 2x. So that would leave me with 7x over 2x plus 6 over 2x equals 6x over 2x. All of our denominators are the same. I no longer need to worry about them. So I'm just left with 7x plus 6 equals 6x. We're going to subtract 7x from each side and get 6 equals negative x. Divide each side by negative 1. I get negative 6 equals x. My only denominator with an x It's just x itself, so I would plug in -6, and that's not 0. So that would be our answer. X would equal -6. Number 7 is where we can make this problem a little bit easier on ourselves because 2 of the 3 fractions have a common denominator. So what I'm going to do here is I'm going to use some basic equation math and combine them that way. So I see the 4 over x minus 1 can combine with x plus 1 over x minus 1 because they have the same denominator. So I'm going to subtract 4 over x minus 1 from each side. 3 over 2 equals, I'd have x plus 1 minus 4 over x minus 1. That would simplify to x minus 3 over x minus 1. Now that I have one fraction equal to another, I can just go ahead and cross multiply. So I'd have 3 times x minus 1 equals 2 times x minus 3. So again, I'm just distributing on each side, and we're going to simplify. And eventually, you end up with x being equal to -3. Again, I can plug -3 in for x into my denominators. It doesn't make anything 0. In the denominator, life is good. There we have our x value. Number 8 here is the exact same type of problem as number 7. You'll see with number 9, same thing here. So we can shorten this process up a little bit. So I'm going to combine the fractions that have the denominator of 2x with each other. So I'm going to add 5 over 2x to each side. So I'll have 3x over x plus 1 on the left. Right side, 3 plus 5 would make 8 over 2x. Cross multiply by doing 3x times 2x equals 8 times x plus 1. So I'd have 6x squared on the left, 8x plus 1 on the, 8x plus 8 on the right. I'm going to go ahead, since this is a factoring problem because we've got an x squared, we're going to subtract 8x and 8 to the other side. 6x squared minus 8x minus 8 equals 0. Now, you can do this one of two ways. You can go straight to the diamond from here, or you can recognize, hey, we've got a GCF I can take out of these. We can take a 2 out and then go to the diamond. You'll still be able to solve it either way, but if you at least can take the GCF out, it'll make the factoring, the numbers a little bit smaller, might make it easier to think of what actually goes together. So once I take the 2 out, technically you can divide that away because we're solving that as an equation, and I'm just going to be left with 3x squared minus 4x minus 4 equals 0. And again, you're going to factor that. So adds to -4, multiplies to a times c, which is -12. The two numbers that'll do that are -6 and +2. So we could say 3x squared minus 6x plus 2x minus 4 equals 0. Break it apart. Take out a 3x, be left with an x minus 2. Take out a 2, be left with an x minus 2. You'd have 3x plus 2 times x minus 2 equals 0. And then solve each. So we'd have two answers here. You'd have x equals -2/3 and x equaling 2. Plug them both in for your denominators. Nothing turns to 0. You've got yourself two final answers there. And in the last problem, again, two of our fractions have common denominators, so I'm going to put them together. So I'm going to move the 10 over x minus 2 by subtraction. So I'd have 5x minus 10 over x minus 2 equals 7. I'm going to rewrite the 7 as 7 over 1 just so it's visually easier to cross multiply. So I'd have 1 times 5x minus 10 equal to 7 times x minus 2. So 5x minus 10 equals 7x minus 14. Subtract over the 5x, I'd have 2x minus 14 on the right. Add 14. I end up with 4 equals 2x. Divide by 2. X would equal 2. Now, here's a weird case here. Again, we're always checking. So if I plug that 2 into the denominator, both my denominators that have x's, well, if I do 2 minus 2, that gives me a 0. That's a problem. When I have a problem like this here where I checked it, didn't work, if that's the only answer I've got, this technically has no solution. So it's a rare case, but it can happen where you only get one x value. Just because it's the only x value doesn't mean you don't check it. There are times where you can get an x value that looks totally fine, but you plug it into the denominators and you've got a problem. It doesn't actually work because you end up dividing by 0 when you plug that in. So all being told here, 2 different ways that you can solve these fractional equations. Again, the cross-multiplying strategy is wonderful if they're set up in a way that's going to allow you to do that. We're always simplifying, we're always factoring. So again, it's taking all these different skills you've learned this chapter and in the past several and combining them together. So you do need to know how to find least common denominators. You need to be able to factor, add, subtract, multiply, divide, all that stuff. So that's how you go about simplifying and solving rational equations.